Download this code from codegive.com, link in the description below. OK, let's dive into the broken pipe error you might encounter while running the test.py script within the Coqui TDS ecosystem, specifically in the context of the GitHub project. This tutorial will break down the error, its potential causes, how to diagnose it, and provide practical solutions and code examples to help you troubleshoot and resolve it. Understanding the broken pipe error. The broken pipe error, often reported as ioerror, errno 32 broken pipe, is a common I/O error that arises in inter-process communication (IPC) scenarios, typically when you have a pipe, a unidirectional data channel, connecting two processes, and one process tries to write to the pipe while the other process at the receiving end has closed its reading end. In simpler terms, it's like trying to send a message through a tube where the recipient has already disconnected their end. Context: Coqui TDS and test.py. Coqui TDS, text-to-speech, is a popular open-source library for generating speech from text. The test.py script in the Coqui TDS GitHub repository is usually a suite of unit tests designed to verify the correctness and functionality of various components within the TDS system. These tests often involve multiple processes, models, and data streams, making them susceptible to inter-process communication issues like broken pipes. Why broken pipe occurs in Coqui TDS tests. Here's a breakdown of potential reasons why you might encounter this error in Coqui TDS tests. 1. Process termination/crashes *, one of the most frequent causes. A test case might launch sub-processes, example model loading, audio processing, validation. If one of these sub-processes encounters an unexpected error, crashes, or is terminated prematurely, the pipe connecting it to the main testing process gets closed. When the main process attempts to send data, example text for synthesis, validation data, to the terminated sub-process, a broken pipe error occurs. 2. Timeout issues *, some tests might have implicit or explicit timeout durations. If a sub-process takes longer than expected to complete its task, the main test process might prematurely kill it, leading to the broken pipe situation. This is common in tests that involve large models or complex computations. 3. Resource contention * in environments with limited resources, CPU, memory, GPU memory, sub-processes might struggle to allocate the necessary resources, leading to failures and, consequently, broken pipes. This is especially relevant when dealing with large TDS models and long audio sequences. 4. File system issues * some tests might rely on temporary files or directories for storing intermediate data. If there are issues with file system permissions, disk space, or file corruption, sub-processes might fail to read or write these files, triggering errors that lead to process termination and broken pipes. 5. Signal handling * signals, example sigterm, sigint, can be sent to processes to control their execution. If signal handling is not implemented correctly, a signal might unexpectedly terminate a process before it has completed its communication, resulting in a broken pipe. 6. Threading issues * if the test.py or supporting modules use threading, race conditions or deadlocks can lead to premature thread termination. Processes relying on those threads can then experience broken pipes when trying to communicate. 7. Model loading problems * if the test attempts to load a TDS model that's corrupted, incompatible, or missing, the model loading process might fail and close the pipe. 8. Data stream errors * TDS processes often handle large data streams, text, audio. Corrupted or malformed data within these streams can cause errors during processing, leading to process termination and a broken pipe. Diagnosing the broken pipe error. 1. Examine the error message and trace back asterisk. Asterisk. The trace back is your first clue. Look for the exact line of code where the ioerror, errno 32 broken pipe occurs. This will tell you which part of the Coqui TDS system is attempting to write to the closed pipe. Asterisk. Pay attention to which test case is failing. This will narrow down the scope of the problem. 2. Enable verbose logging asterisk. Asterisk. Modify the test.py script or its configuration to enable more detailed logging. Look for options to increase verbosity or enable debugging output. This will provide more information about what's happening inside the subprocesses. 3. Inspect subprocess output asterisk. Asterisk. If the test.py script launches subprocesses using subprocess.popen, capture their standard output and standard error streams. Print these streams to the console or save them to files. This will reveal any errors or warnings that the subprocesses encountered before they terminated. 4. Use a debugger, PDB, IP. Asterisk. Insert breakpoints in the test.py script using the Python debugger, PDB or IP. Step through the code line by line to observe the state of variables, the flow of execution, and any errors that might occur. This can help you pinpoint the exact moment when the pipe is broken. 5. Resource monitoring asterisk. Asterisk. Use system monitoring tools, example top, HTOP, Vmstat, NVIDIA to monitor CPU usage, memory usage, GPU memory usage, and disk I/O during the test execution. This will help you identify resource bottlenecks that might be causing subprocesses to fail. 6. Reduce parallelism asterisk. Asterisk. If the tests are running in parallel, try reducing the number of parallel processes or threads. This can help alleviate resource contention and make it easier to diagnose the problem. 7. Simplify the test case asterisk. Asterisk. If possible, isolate the failing test case and run it in isolation. Remove any unnecessary dependencies or configurations to simplify the environment and make it easier to identify the root cause. 8. Environment checks asterisk. Asterisk. Double check that all necessary dependencies for Coqui TDS are installed correctly, especially any native libraries, example CUDA drivers, audio codecs. Ensure that the versions of these dependencies are compatible with the Coqui TDS version you're using. 9. Reproducibility asterisk. Asterisk. Try to reproduce the error consistently. If the error only occurs intermittently, it's harder to diagnose. Try running the test multiple times under the same conditions to see if you can reproduce the error reliably. Code examples and solutions. Here are several code examples and solutions to address common causes of broken pipe errors in Coqui TDS tests. I'll focus on areas where you can make changes to the test.py script or related modules to improve error handling and debugging. 1. Capturing subprocess output and errors. Explanation asterisk. Asterisk. Subprocess.popen with stout equals subprocess.pipe, str equals subprocess.pipe asterisk. This is the key. It creates a pipe for both standard output and standard error from the subprocess. Asterisk. Text equals true asterisk. This is crucial in Python 3.7 plus. It ensures that stout and str are returned as strings, Unicode, not byte streams. If you're dealing with byte streams, you'll need to decode them using .decode, UTF-8, or a suitable encoding. Asterisk. Process.communicate, timeout equals 60, asterisk. This reads the output and error streams from the subprocess, but also includes a timeout, 60 seconds in this example. This prevents the main process from hanging indefinitely if the subprocess gets stuck. Asterisk. Process.return code asterisk gets the exit code of the subprocess. A non-zero exit code indicates an error. Error handling. The code includes try, except blocks to catch subprocess. Timeout, expired exceptions and other unexpected errors. This allows you to handle timeout situations gracefully and provide informative error messages. It avoids silent failures. How to use it in a test. 2. Signal handling. If signals might be interfering with your subprocesses, you can try resetting signal handlers in the subprocess. Explanation. Preexec_fn equals preexec_fn*. This function is called before the subprocess is executed. Signal.signal, sig, signal.sig_dfl, this resets the signal handlers for sigint, sigterm, sigquit, and sigpipe to their default behavior. Specifically, we include sigpipe as handling it incorrectly can be a source of broken pipe errors. This is a critical step to prevent signal interference. 3. Using try, finally, to clean up. If your test creates temporary files or directories, ensure that they are cleaned up properly, even if the test fails. Explanation. Temp file.temp, creates a temporary directory. Try, finally, guarantees that the code in the finally block will be executed, regardless of whether an exception is raised in the try block. Shuttle.remtree, temp_dir, recursively removes the temporary directory and all its contents. Path, from pathlib, provides a more modern and object-oriented way to work with paths. It's generally preferred over os.path. 4. Error handling within TDS model loading. If you suspect that model loading is the problem, add error handling around the model loading code. 5. Adjusting timeout values. Increase the timeout value within process.communicate, if you suspect that the subprocess is simply taking too long. Important considerations. Coqui TDS version. The specific classes, modules, and methods you use will depend on the version of Coqui TDS you are working with. Adapt the code examples accordingly. Virtual environments. Always use virtual environments, VNV, Conda, to isolate your Coqui TDS installation and avoid conflicts with other Python packages. GPU memory. If you're using a GPU, monitor GPU memory usage. Large TDS models can consume a significant amount of GPU memory. Try reducing batch sizes or using a smaller model to reduce memory pressure. Documentation and community. Consult the Coqui TDS documentation and community forums for specific troubleshooting advice related to your version of Coqui TDS. Reproducible examples. When seeking help from the Coqui TDS community or reporting issues, provide minimal, reproducible examples that demonstrate the problem. This will make it easier for others to understand and assist you. Debugging checklist. 1. Traceback. Analyze the traceback to identify the failing test case and the line of code where the broken pipe error occurs. 2. Logging. Increase verbosity and capture subprocess output/errors. 3. Subprocess monitoring. Use subprocess.popen with stout equals pipe and stare equals pipe to capture output. 4. Timeouts. Implement timeouts to prevent hangs. 5. Resource monitoring. Monitor CPU, memory, and GPU usage. 6. Temporary files. Ensure proper cleanup of temporary files. 7. Model loading. Add error handling around model loading. 8. Environment. Verify dependencies and virtual environment setup. 9. Reproducibility. Create a reproducible example. By systematically applying these diagnostic techniques and solutions, you should be able to effectively troubleshoot and resolve broken pipe errors in your Coqui TDS tests and ensure the stability of your TDS system. Remember that the key is to gather as much information as possible about the error, isolate the failing component, and handle exceptions gracefully. Good luck.